let's do an overview of even functions. So if a function is even, like this picture in purple, which is x squared, the parent quadratic function, then it is symmetrical about the y-axis. So what does that mean? That means, looking at the y-axis here, if I travel 2 units to the right, then I should see the exact same point 2 units to the left. Or if I travel 1 unit to the right, always in respect to the y-axis, I would travel 1 unit to the left. So we could say that the right side of the graph is exactly the same as the left side, or you could think of this graph, if you actually fold it along the line, the y-axis, the graph would match up. And you'll also notice that the graph belongs in quadrants right next to each other. This is quadrant 1 and this is quadrant 2. So they're side by side. So another example besides this U-shape of a graph that is also symmetrical about the y-axis would be a horizontal line. For instance, this line, which has an equation of y equals 2. It is symmetrical about the y-axis. The right side is the same as the left side, and the graph belongs in quadrants right next to each other. So let's take a look at some ordered pairs. Let's start with the purple graph, and let's actually fill in some of these ordered pairs. So this first point here would be 2, 4. So something unique about even functions is the following. If this first coordinate is 2, 4, if I look at the opposite sign of x, so if I go 2 to the left or -2, the height should be exactly the same. It should still be 4. If I look at this ordered pair here, which has coordinates of 1, 1, so when I chose 1 for x, the height was 1. If I go 1 to the left, so if I take the negative value, my height should be exactly the same, which it is. It's +1. So that happens for every single even function that is symmetrical about the y-axis. And in fact, I can look at my second picture here where I have y equals 2 and see that I get the exact same thing. So this ordered pair is 1, 2. So when I chose my x value as +1, if I choose it now as -1, then my height would be exactly the same again, +2. The height being the y value. So there is a rule that we can derive from this observation that when you pick the positive x value and just the opposite sign of that x value, you get the same height. So that rule looks like this. So f of x. So first of all, f of x. What is that saying? That's saying plug in x into your function. When you plug in x, that is the exact same answer as when you plug in -x. So plug in -x. So let's take a look at actually using the numerical values to see why this rule is true. So for my quadratic, I'm going to use the 2, 4 and the -2, 4. So if I plug in 2 for x, right? That should have the same answer if I plug in -2 for x. And it was the same answer. F of 2 is saying, what is the y value when you plug in 2? The answer was 4. F of -2 is saying, what is the y value when you plug in -2? And it was also 4. So this rule holds true for all even functions.